All right, here we go. Unit 4, Lesson 1, Simplifying, Multiplying, and Dividing Rational Expressions. Rational expressions, big scary term, but it is just a fancy word for fractions. It is just a fancy word for fractions. Comes from this word ratio, right? You're comparing one term to another. And one way we can do that is as a fraction, a numerator divided by a denominator in a ratio. So we're going to expand on the operations that we know how to do since elementary school on numbers, and we're going to expand and apply those same techniques to polynomial terms. So one thing we've learned how to do, right, is to take an expression like 20 divided by 45, and we've learned how to simplify this expression. So we could simplify this expression, yes, we could do to decimal and calculator and then back to fraction, but we could also do things like, okay, we can divide the numerator and the denominator by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. So we can use that to simplify our rational expressions. When we're multiplying rational expressions, you need to remember that to multiply two fractions is to multiply straight across the top, straight across the bottom. So for example, if you had a half of a half, right? You had half a pizza and you tore that in half, you'd have a quarter. So we have 1 over 4. Same thing applies here. We'd have 150 divided by 42. I could divide both of those by 2 to get 75 over 21. And I could divide both of those by 3 to get 25 over 7. Last thing that you need to remember is that when we divide fractions, it is the same thing as flipping the second one and multiplying. To go back to the pizza example, if I wanted to know what 4 divided by 1/2 is, that's asking how many 1/2s fit into 4. So if you had 4 pizza pies and I wanted to know how many half pizzas fit in those pans, 1, 2, 3, 4, 5, 6, 7, it would be 8. Because 4 divided by 1/2 is the same thing as 4 times 2 over 1, which is 8. So what this is equal to is 15 over 6 times 12 over 20. So we could do this all out. We'd have 180 divided by 120, right? 180 divided by 120. We could divide those both by 10 to get 18 over 12. We could divide those both by 6 to finish with 3 over 2. And the process that we're going to build upon here is one other way to think about these simplifications is that you can do them from the beginning. So let's say we just thought of 20 automatically as 5 times 4. And we thought of 45 automatically as 5 times 9. Well, the 5s would cancel and we'd be left with 4 over 9. We'd be left with 4 divided by 9. This process also works. I'm going to take each of these and break them up. So 10, I know 10 is 5 times 2. I know 15 is 5 times 3. I know 6 is 3 times 2. 7 is a prime number. So if you break these all up into their prime numbers, well, we can just start canceling from the get-go. 2 and 2 divide to make 1. 3 and 3 divide to make 1. If you do it from the beginning, you don't even have to do that original multiplication. You just get straight to 25 over 7. Same thing here. If we swap the division out for multiplication, well, it's 12 over 20. And I just start to break these things up. I say 12, well, that's 2 times 2 times 3. 20, that's 2 times 2 times 5. 15, that's 3 times 5. 6, that's 3 times 2. And I start to cancel all of these things out. 2's cancel, 2's cancel. What you would wind up here with, the 5's cancel, all you'd be left with is the 3 over 2. So the idea here is that if you can break it up from the beginning, you can save yourself a lot of multiplication time. Let's see what this looks like as a rational expression. So same ideas here, but just instead of breaking up numbers into factors, we're going to break up expressions into factors. So I'm going to take 2x squared minus 6x, and I'm going to factor out a greatest common factor. They both have a 2 at least. 2 and 6 can both be divided by 2, and they both have at least an x. So we'd have 2x times, well, 2x times x would get me 2x squared, and 2x times negative 3 would get me negative 6x. So that is my top expression factored. On the bottom, x squared minus 9 is an example of the difference of squares. It would be x plus 3 times x minus 3. So the x minus 3's would divide to make 1. Final answer here, 2x over x plus 3. So that is one example of simplification. Here's another one. X squared minus 2x minus 15. Okay, this is going to be one of our trinomials here. I know we need an x and an x. In order to get minus 2 in the middle and two numbers that multiply to make negative 15, I must have a minus 5 and a plus 3. On the bottom, we once again have the difference of two squares. Notice how often it comes up. The x minus 5's will cancel. Your final answer here, if all we're being asked to do is simplify, is to have x plus 3 over x plus 5. Now where this becomes really useful, so we could do a few more of these. These are all just more practice problems that we could do. When this becomes really useful is when, we'll come back to that part, when this becomes really useful is when we are multiplying or dividing these rational expressions. So when we're multiplying or dividing them, yes, we could multiply these all out, but we'd have to do like 2 times x squared and 2 times x and 2 times, and just all of these things would have to get multiplied. It's much easier to see if we can figure out what can be factored out of each of these. So for example, 2x squared plus 2x, we could factor as 2x times x plus 2 over x squared minus 1, that's the difference of squares, x plus 1 times x minus 1, times x plus 2 times x minus 2, times x minus 1 to make x squared plus x minus 2 over x minus 3 times x plus 2. Notice that's just each of these 1, 2, 3, 4, 1, 2, 3, 4. Pause the video to check those out if you're having a little trouble seeing that. Now we can start our big cancellation. The x minus 1 and the x minus 1 will divide to make 1. X plus 2 and x plus 2 will divide to make 1. This looks like all we've got left. So we've got here, final answer, this is 2x times x plus 2 over x plus 1 times x minus 3. Let's do one more here since we've got time. Same thing, 1, 2, 3, 4. We're going to factor and see what we can cancel before we multiply. So 4x squared minus 1 would be 2x plus 1 times 2x minus 1, because 2x times 2x is 4x squared. Positive and negative 1 multiply to make negative 1. In the denominator, I'll need 2x and x, and then I would play around for a while. Two numbers that multiply to make positive 3 but add to make negative 7 when you add their terms in the middle. This needs to be a minus 3 and a minus 1. Again, reason is in the middle, you'd have negative 6x minus 1x when you do that multiplication out. Now all of this is going to be multiplied by x plus 3 times x minus 3, the difference of squares, over x plus 3 times x plus 3. And so we can start canceling. The x plus 3's cancel, and x minus 3 cancels, a 2x minus 1 cancels. What we're left with is 2x plus 1 over x plus 3. The only thing to really remember here, one more thing to remember here, is if you have and we'll finish up, this will be the last one, if you have a division problem like we do in the bottom right, don't forget that you have to flip the second expression. So I'll label these here 1, 2, 3, 4, and we'll flip it when we factor. So number 1 will factor as 3x and x, and now we need a negative x in the middle. So this is going to have to be a -1 because it'll make negative 3x in the middle when it multiplies, and this will be a +2. So that's our first factoring. Denominator, our favorite, the difference of two squares, x plus 1 times x minus 1, times, now I'm going to flip these, and so in the numerator is where I'm factoring x squared minus 3x plus 2. And so here we're going to have, in this case, both need to be negative, x plus 2 times x minus 2. The denominator, 9 plus 6x, there is nothing, or sorry, 9x plus 6, I guess, yeah, what we can cancel here is they both have at least a 3. 3 times 3x plus 2. And that makes sense because these usually work out so that you can have things that divide to make 1. So 3x plus 2 and 3x plus 2 divide to make 1. X minus 1 and x minus 1 divide to make 1. That looks like all we've got here. So our final answer here will be x minus 2 times x minus 1 all over x plus 1.